Section 14.4 is surface area. So we've been talking in section 14.2, I think it was, about area of two-dimensional shapes. So what surface area is surface area is going to be the two-dimensional shapes that make up three dimensions. So if you imagine wrapping paper, okay, you're wrapping a box. The space inside the box is what we call the volume. It's what it actually holds. The space around the box is the surface area, the part where the wrapping paper would be. So a little bit more formally, we'll do surface area now. The number of square units that is needed to cover a three-dimensional surface. Kind of like the wrapping paper description a little bit better. But this is the official one. There's two types of area we can talk about. We can talk about lateral area. So lateral area is the sum of the lateral faces. So lateral means around the side. Okay? The items that are on the top and the bottom we call the bases, if you'll remember that from when we did three-dimensional stuff back in chapter 11. Bases on the top and bottom. So lateral area is around the sides, bases are on the top and bottom, and if we're talking about surface area as a whole, it includes all of that. The around the side, the lateral, plus the two bases. And of course this picture is of a pentagonal prism, right? Yes, so long ago, pentagonal prism. Specifically, we're going to look at formulas for finding surface area. Sometimes it's easier to break the shape down into what's called a net. So a net is just, if you imagine just taking that piece and cutting it along its edges and laying it flat, you have a net. So the first shape here on the left, what is that shape? That's a cube. And then the shape on the right is at least one of the versions of a net that you could get if you broke it down and laid it flat. So if you're taking a look at this particular shape, we're going to calculate or come up with an equation or a formula for the surface area for this shape. All right, so tell me what you remember about a cube. It's made up of squares. And how many of them, Erica? 6. It's made up of 6 squares. What do you remember about the area of a square? It's length times width, but specifically because it's a square, it's side squared, because the length and the width are the same. So the area of any one of these individual bases, we'll just take the bottom one so that I can point to it. The area down here would be side squared, correct? And Erica said there were how many? There's 6 of them. So if I were to add up s squared 6 times, I would get 6 times s squared. And that's the formula for the surface area of a cube. Whole bunch of squares added together. Now, a cube is a form of the next shape. It's just that it's so simple that it has its own formula because it's so much easier to just use it like this, okay? Cubes are very nice and friendly. But in general, a cube is a right prism, so you could calculate it as we're going to calculate the following. If B is the area of a prism's base, capital B, okay? P, lowercase p, is the perimeter of the base, and H is the height of the prism. What is a formula for the surface area of a right prism? Okay, so the picture, of course, here again is the pentagonal, I think it is, yeah, pentagonal prism, right? And we're trying to calculate the area, surface area of this shape. So taking a look, it already told us that the area of the top and the bottom are B. So we're not getting a formula for that. That's going to be based on what kind of shape we have on the top and bottom. If you have a triangle, you're going to need the area of a triangle. In this case, it's a pentagon, you'd need the area of a pentagon. And we already know how to calculate those, even if we don't remember it off the top of our head. We've done that, okay? And we can go back and we can find that information. But all of these shapes in the middle are what? They're all rectangles. And how do you calculate or find the area of a rectangle? Length times width, or base times height, whatever it is that you're using. And if you'll notice, these heights are all the same. Agreed? And so are the bases, because it is a right pentagonal prism. Okay? So we've got the same base all the way around. However, even if they weren't, we can use another piece of information that this problem sets up. It tells us that the perimeter is P. So what is perimeter? What does that mean? Yeah, the outside edge of the base. So what is the outside edge of this base with the letters that they give us? S1 plus S2 plus S3, and if they're all the same, we would have 5S, right? If they were all actually the same. But even if they're not, the perimeter is still all of them added together. Agreed? So let's, for the moment, suppose that these weren't actually all the same. They wouldn't have to necessarily be on every shape. We would have calculated the height times S1 plus the height times S2 plus the height times S3, S4, and S5, right? That would be those 5 areas of those 5 rectangles all added together. Agreed? But what do they all have in them that's for sure the same? H is for sure the same. S might be the same if we have a regular shape, right? So the H for sure is the same. So we're going to do just a tiny bit of algebra. We're going to take the H out in front. And if I take the H out in front, I would have S1 plus S2 all the way to S5. And what's another name for S1 plus S2 all the way to S5? P. It's the perimeter. Adding up all of those S's is the same as adding up the perimeter of the pentagon. So, let's write down a formula. We already said that we have 2 bases. That's 2b. Okay? Plus, we have the height times the perimeter. H for height, P for perimeter. Okay, everybody good with that? And that's really nice because that means it doesn't matter whether the actually is a regular pentagon. Even if it's irregular and all those S's were all different, you could still use this formula by adding all the S's together to find it. So that's friendly. We're going to do a couple of one example, and then we're going to move to cylinders. This one says to find the formula for a surface. I guess it's not exactly it. It's not at all an example. I totally take it back. It looks like one. It says example on my page, right? All right. It says find a formula for the surface area of a right rectangular prism. It is not length times width times height. What would that be a formula for? That's actually the volume, which we will encounter in 14.5. So don't be led astray. The formula that we just had above said that what I should be able to do is I should be able to take 2 times the base plus the height times the perimeter. So let's see if we can use that sort of general formula for a right pentagonal, well, we didn't use pentagonal, a right prism, to do the same thing for this one. All right, the base would be this bottom part right here. What is the area of this bottom part that I just scribbled in pink? Length times width. So if I go over here, I've got 2, and then I've got length times width. Does that make sense? And why is it 2 of them? Yeah, there's one on the bottom and there's one on the top. So let's say somebody got super creative and they told you you had an opened box. That would change things, right? You just have one of them. Okay, so just something to be aware of. All right, height. What is the height in this oh, it's actually H, isn't it? Isn't that fun? The height of our object's actually written that it's H. Fabulous. And then it says the perimeter. So what is the perimeter? Okay, what is it the perimeter of that we're trying to find? Okay, the perimeter of the base. So looking at this shaded ugly and pink base that I have, what's the perimeter? 2L plus 2W. Right? It's this piece and this piece and this piece and this piece all added together. Now there's nothing wrong with leaving my formula like this, except that it probably doesn't look like the formula you're used to seeing if you have seen this surface area formula before. So what I would like to show you is that it is the same if I distribute the H through. This is 2 length times width plus 2 height times length plus 2 height times width. And if you think about this particular shape, it makes sense. The bottom is length times width, and the top is length times width. What about this right-hand side over here? What is its area? Height times width. And it mirrors over here to its area on the left-hand side, which is also height times width. What about the sort of front, the front part of the box that's facing us? Right, it's height times length, and its mirror image at the back of the box, the hidden side you can't really see, is also the same. So there's three separate shapes that are duplicated in this particular box, because that's how boxes are created. I mean, like, that makes sense to us for a right rectangular box. All right, let me do one more formula so to finish front page, and then we'll start with the next example next time. Cylinders. If I were to take a cylinder, so again, imagine like a soup can or a soda can or something like that, and I were to cut it apart, its net would be the shape that we have on the right-hand side. It's got a circle for the top, a circle for the bottom, and it's got a rectangle that's actually the long piece around it, right? Okay, so let's figure out what the surface area should be for this. Well, in general, there are two bases, right? This base on top, base on bottom. We're going to get an equation for those a little bit more specifically in a moment. And then this should be a rectangle in the middle that we're adding together. Well, the rectangle has a length and a width, or a base and a height. The height is labeled as h. And the width is labeled as 2 pi r. Any idea why it's 2 pi r? It's the circumference of the circle. That's what it is, 2 pi r. You got it. Now, more specifically, the bases on the top and the bottom, at least for a regular shape, would be a circle, right? Because this says right circular cylinder. What's the formula for the area of a circle? Pi r squared. So I have 2 because there's a top and a bottom. And then I have pi r squared. And then I have h times 2 pi r. So if I clean it up just a little bit, I've got 2 pi r squared for the top and the bottom, plus 2 pi r h for the lateral area, the area around the object. And we will pick up with an example, and I think it's of a soup can. Yep, a soup can next time. And I'll see you guys on Wednesday.